Hi, my name is Eric Yam, and I'll be showing you how to render ice. This is an artist's guide to rendering ice, so the information has been simplified. We'll also be talking about water-based ice in this guide. Now there's two important things to know about rendering ice: color and specularity. A common question about the color of ice is why is ice sometimes blue and sometimes transparent? The reason ice is blue is because of scattering. A glacier is blue, and ice cubes are not, because glaciers are made up of dense snow crystals, while ice cubes are created from a slow cooling process. The density of a glacier makes it difficult for light to pass through. Because of this, only the wavelength of blue makes it through the glacier. This is also the reason why glaciers seem opaque. Ice cubes are less dense, and light has no trouble passing through the small crystals which create an ice cube. This is why ice cubes also seem transparent. Now, because a glacier is large and dense and an ice cube is small and not dense, doesn't mean that they're both not ice, but they both just have different properties. So let's say you take a 1-inch cube of like an ice cube that you take out of your refrigerator, and then you go up to a glacier and you cut out a 1-inch cube. They should technically be the same thing, but the ice cube you take out from the glacier will be more dense and will also will also stay frozen a lot longer than the ice cube you take from your fridge. So there's also different specularities of ice. Let's say, in particular, snow versus a glacier. Snow has dense crystals, but it is not densely packed when it is freshly fallen. So a snow patch is more porous than a glacier because they haven't been compressed and compact. Because of the porousness of a snow patch, light doesn't have to travel very far in order to be reflected back out of the snow patch, versus a glacier where light can be trapped inside the glacier and then has a hard time getting out. This is why when you look at a snow patch in the sun, it'll have a very high luster or specularity versus a glacier in the sun, which is more likely to absorb the light and trap it. So what to take away from what I just said is a snow patch reflects light, doesn't absorb it very well, and that gives it a high luster, while a glacier, on the other hand, absorbs light and it gives it a low specularity and luster. So, after hearing that, I have a few examples of good and bad art of snow. This is an episode of Pokemon which recently aired on the internet, and the thing about it was, what immediately stuck out for me is this scene right here. Now, there's a lot of things wrong with this scene. The first thing that stuck out in my mind was this tree. Now, I can see that this scene has been frozen over and everything is covered in ice, but it's fairly ridiculous that this tree, even though it's being flash frozen, is is blue. The reason why this is ridiculous is because the snow, if it was flash frozen, that means the crystals would be small because it wouldn't have had time to absorb moisture in the air, giving it big crystals. Not only that is so the tree is blue, which is ridiculous because in order to be blue, it would have to be very compact, a very compressed snow, and that wouldn't and by the judging by the size and everything of it, that's not happening. So this tree is obviously fake. The next thing that stuck out is the ground, which is a little pushed. I can understand why it would be blue because maybe the sky that's very blue in this scene, later in the scenes, it shows that the sky is blue, but it seems abnormally blue. And then the last thing that I noticed is these ice crystals that are like jutting out from who knows where, and that they're very dense and blue. The thing with these is that if they were created from, like, let's say a Pokemon where it immediately cooled water, they wouldn't be like this opaque and blue. They would be very transparent and very icicle-like, such as right here. This is what you would get, not this. So this whole scene is pretty much wrong in terms of ice, but nice try.